Good afternoon, everyone. Good afternoon, Yashashvi. Good afternoon, Shushma. Good afternoon, computer lovers. Good afternoon, Alpana. Good afternoon, Kusum. Good afternoon, Rohit. Yes, I'm fine. Good afternoon, Kulwant. And good afternoon, Soumya. Please give a confirmation. Audio, video clear aa rahi hai? Good afternoon, Deepak. Good afternoon, Vijay. Good afternoon, Jyoti. Okay, so audio, video, I think is clear from my end. You know, I have checked it, so it's clear. Okay. Good afternoon, Kirti. Good afternoon, Priyadarshini. Okay, chalo. So all those who are new here, so this is the 1000 question series that we have started, right? We have already completed TOC, that is theory of computation, compilers, operating system, and we are now doing DBMS, right? And we have covered topics like your ER diagram topic we have done, and then we have discussed few questions on your functional dependencies as well, right? And today we will be doing the topic that is your normal forms and then lossless decomposition and all those type of questions, right? I have already shared the whole schedule with you of the entire week. I hope you all have seen it. Yes. So I have told you that after DBMS, that is after database management, we will be starting with data structures. So all those who are here and who want to know what after DBMS we will have, so we will be doing data structures. Just let me find it. Yeah, right. And I have already told you that in your evening classes, what we will be doing in evening classes, we will be discussing previous year papers. We will be discussing paper 1 also and paper 2 also. Both the papers we will be discussing, right? So good afternoon, Somla. Good afternoon, Teach Come Tech. Hello, Dhanshri. Chalo. Good afternoon, Preeti. So let's start our class, and all those who are new, you can join the Telegram group as well, where I just inform everyone regarding the classes, regarding I just provide different PDFs, provide short notes, so you can join it. That will be beneficial to you. Okay? Then, so we have to start from this question. So this is the question. This question I also gave in what you say in the assignment, that assignment type of thing that I gave you, right? Where I gave 10 questions around. So I gave this question as well. Okay, so what they are saying, suppose the following functional dependencies hold on a relation U with attributes P, Q, R, S, and T. So these are the functional dependencies given to you. P is functionally dependent on Q, R, RS is determining T. So Acha, I hope you all know this thing. Just let me just clarify it, that if I have A dependent on B and C, so I can write it as, I can, if I want to separate it, I can write it as A dependent on B and A dependent on C, right? But if I have that AB is dependent on C, so I cannot write A dependent on C and B dependent on C. This is not right. This is what can be written. I hope you all are aware of this fact. Hello, Javed. Yes. So always remember this, that this thing can be broken down into these two things, but I cannot break this thing into this. Why? Because A and B combined are determining C. Okay. So this is like this, that if I have A, B and C, and if I have 1, 2, 1. Okay. And this is again 1 and 3, and suppose this is 4. So if you see now, A is not dependent on C. A is not functionally determining C, right? 1 say 4 and 1 say 4. I'm having same. But they are saying that combination of A and B. It's like it would have been 1, 2. This would have been 2, 4. And it would have been 1, 5. So this combination is functionally determining C. Okay, so please remember this. Hello Sharanya, that how you are breaking. This breakage is not possible. This you can break. Okay. Okay, so moving on to the previous question. So now they're saying which of the functional dependencies can't be inferred, okay? Can't be inferred from the above functional dependencies. From these two functional dependencies, which functional dependency I cannot infer? So try and tell what will be the answer. How you will do this? It will be done by simply that you will take one option, right? And then you will see whether I am able to determine PS. If I take closure of PS, so whether I will get T or not. And I hope you know this, that PS closure आप इन दोनों में से find करोगे, right? So if I find PS closure, so I will have P, I will have S, then P will determine Q, R, then R and S will determine T. So from P, by taking the closure of PS, I am able to get T. So this can be inferred, right? Very easy it is. Then we will find the closure of R. So when we find the closure of R, and closure you will find from these two only, right? ये ध्यान रखना. So by closure of R you will get only R. You are not able to get T. So this is what I cannot infer. Again, if I take closure of P, so what I'll get? P, Q and R. So P to R, P and R, it is inferred correct. And PS, so PS closure already took, it is deriving Q, so this is also can be inferred. So the correct answer is option number B, as option number B can't be inferred from the functional dependencies. Clear? So very easy question. Many students were having doubt in this question while I gave the assignment. I don't know why. Very easy question it is. Okay, so now this question is your lossless and lossy decomposition. So consider the relation R P Q S T X Y Z W. So you have how many variables? 1, 2, 3, 4, 5, 6, 8 variables you have. P Q S T X Y Z W with the following functional dependencies. So you have 1, 2, 3, 4. 4 functional dependencies are given to you. They are saying consider the decomposition of the relation R into the constituent relations according to the following two decomposition schemes. So they have decomposed your relation R into two decompositions, D1 and D2. So D1, that is R, is decomposed into 4 tables, 4 relations. P, Q, S, T, PTX, QY, YZW, and decomposition 2 may be R is divided into 4 tables, PQS, TX, QY, YZW. So you have to tell that which of the following options is correct. So just write down these. I'll zoom in this for you. Okay, just write these functional dependencies and then I'll zoom in for the decompositions. Please write these functional dependencies somewhere in your notebook. There are 4 functional dependencies and write it properly, okay? PQ is functionally determining X, P is determining YX, Q is determining Y, and Y is determining ZW. गलती नहीं चाहिए इसमें, okay? So I hope you have done it. And now these are your decompositions, D1 and D2. So these are your decompositions, okay? Try it and see clearly how they have decomposed, okay? Quickly karo so that we can do more questions in less time. Otherwise you won't be able to do the questions and then फिर questions रह जाएंगे. D1 is lossless and D2 is lossy. Okay, let's see. Chalo, let's see one by one. So first let's check for D1. Okay, करो आप लोग. Let me just do one thing till then. Yeah. So correct option is that D1 is lossless and D2 is lossy. Okay, so D1 is lossless and option A is the correct answer. Now how option is the correct answer, let us see. So what we have first, let's take D1. Okay, so I'll write over here D1. So D1 is decomposed into P, Q, S, T, right? Then P, T, X, Q, Y, and I think it is Q, Z, and Y, Z, and W. Now, first of all, how we will combine them is that we will take those relations that have anything in common. Now, if you see these functional dependencies, that is PQ determining X, P determining YX, Q determining Y, and Y determining ZW. So if you notice the right hand side, अगर आप देखो यहाँ पे right hand side, so you will notice that P is not there, Q is not there, S is not there, T is not there. Yes or no? So that means my candidate key will contain at least these 4 terms. Definitely. So if I take P, Q, S, T, then I will get X, then I'll get Y, I'll get Z and W. Yes or no? Okay, so now if I take my decomposition table 1, that is D1, so what I saw that, okay, I have this and I have this. I'll take these two things, and what is the common between them? P and T is common, right? So if I take P and T as common, so if you try to find the P and T closure from this, what will be the closure of PT from this functional dependencies? PT you will definitely get. Okay, Q is not there, so I won't get X. P is there, so I'll get Y and X. Yes or no? And Y is there, so I'll get Z and W. But if you see in my table, that is table 1 and table 2, I do not require what you say. I do not require Y. So if I find PT closure, what I got after finding PT closure, I got is PTYXZW. So PTYXZ and W. So now if you see here, I do not require Y. Why? Because from these two tables, that is relation R1 and R2, they are having P, Q, S, T, X. Y, Z and W are not a part of these two tables. Okay, Y, Z and W attributes are not part of any of these two tables. So I can ignore Y, Z and W. So what I'll get? I'll get only P, T and X. Right? And what is the key? How do we find the lossless or lossy here? We find that whatever the common attribute is coming between the two tables, it should always make sure that they have something in common and the common must be a candidate key of any of the relation. I hope you all know this. How do we find the whether the it is lossy or lossless? We find that whatever the attributes are common, it must be the candidate key of at least one of the table. So I can see that pt जो है, it is giving ptx. So I can say that it is basically the candidate key. ठीक है, it is the candidate key of this relation, because if you see here I am getting p deriving yx and p deriving, since y is not a part, so I can say that it is a candidate key of this d1, right? Now let's talk about these two. So what is common in these two? What is common? The common element is y. So now if I find the closure of y, what I will get? If I find closure of y, I'll get y, z and w, right, from these two tables. And yzw is determined by this table, and this was determined by this relation. So now if I combine them, what I'll get? I'll get p q s t x, and if I combine them, what I'll get? I'll get q y z and w. Now how you will combine these two? Yes, how you will combine these two? Yes, everyone. So, yes. क्यों ले सकते हो आप कॉमन? बिकॉज यहाँ पे तो क्यू एस के साथ में है. थिंक ऑफ इट. क्वेश्चन एक बार ध्यान से देखो. So I feel that yes ma'am, q, because super is also allowed now. Super is also allowed, so if I take q. Yeah, so if you see anywhere, matlab I have this question somewhere, so many times, matlab many places में what they have done is they have written it as p q comma s comma t. So if you write it as q comma s comma t, your answer is sorted, है ना? Because अगर आप ऐसे लो, चलो let's take q. Let us take the if we take q as the common element between the two, so what will be the closure of it? If I take q, so if I have q as the, if I take q's closure, what it will be? It will be q, y, z and w. Yes, this is what I get, q, y, z and w. So q, y, z and w, right? So if I take Q, Y, Z and W, so I can say that Q is deriving Y, है ना? So that means that Q deriving Y. So this ways that Q will become the candidate key of this table. Yes or no? And then if Q is my candidate key, then all the super keys that will have Q in it will also become a candidate key. Okay, right? This is the correct. This logic can be applied, but just now I saw somewhere this question. They are having a comma between this, so I'll see to it. कि अगर comma नहीं भी है, then also you can combine it, है ना? So that is why it will say that this is the key of this table, right? When we will join them. So this is what? This is your lossless decomposition. Okay, so अगर यहाँ पे if they would have put a comma over here, then it would have been very good, है ना? बहुत ही अच्छे से we could have easily done it. But अगर comma नहीं भी है, then also if you take the attribute Q as common, then right, super key वाले logic say that if Q is my candidate key, then all the what you say all जो आपकी जो भी attributes हैं that will combine with Q, they will also become part of candidate key. Like if I have QS, है ना? So I'll just check one more time this question, but it is a lossless one. That is your D1 decomposition is lossless. I'll just check it कि whether यहाँ पे comma है या नहीं है, whether it is a single attribute or it's a combination of attribute. ठीक है, I'll see to it. But with this logic also, it is your lossless decomposition. Sorry, lossless join. Let's talk about D2. ये clear है everyone? This is clear? So like now, till now, let's assume that there is no comma between these two. We'll see to it. Now let's talk about D2. So how we have decomposed D2? D2 is decomposed as PQS. यहाँ पे भी I think हो गई, because here also they have divided into different ways, right? PQS, TX, QY and QY and YZ and W. Yeah. Okay, so now let's see. Now if I try to find the common attribute between these two, so I cannot find. चलो कोई बात नहीं. Let's try to find the common attribute between these two. So again same. Y is my common attribute, so Y closure will give you YZW. That will become the candidate key for this one. So this will become, it will remain as it is PQS, TX and QY, Z and W. Now I can combine these two. How I can combine? With the help of Q. So if I take closure of Q, I will get what? I'll get Q, Y, Z and W. But if I have this, it will become the candidate key of this table. So what I'll get now? I'll get P, Q, S, Y, Z and W, and then I'll combine it with T, comma X. But now I don't have anything in common, and since I don't have anything in common, it will become lossy. Okay, so that is why the correct answer is that D1 is a lossless decomposition, but D2 is a lossy decomposition. So you also please check whether we are having QS or we are having Q and S separate. ठीक है, बस चेक कर लेना आप लोग भी. Clear? Now moving on to the next question, this one. So let R, A, B, C, D, E, F be a relation scheme with the following dependencies, that is C, F, E, A, E, C, D, A, B. So which of the following is a key for R? Very easy question it is. क्या समझ नहीं आया श्रन्या? So this one is very easy. What you have to do, you simply have to find the candidate keys. So I can see that F is there, right? On the right hand side, F is there, A is there, D is there, and B is there. So C and E are the two attributes that are not there. So I'll take the closure of C and E. So I'll get CE. Now from CE, I can have F, A, D and B. So I'm having all the attributes. So correct answer will turn out to be option number 2, that is EC. ठीक है शरण्या, क्या समझ नहीं आया? प्लीज डू टेल मी. ओके, right. Process of analyzing relation schemas to achieve minimal redundancy and insertion or update anomalies is classified as normalization of data, denomination of data, isolation of data, or denormalization of data. So what do you think is the answer for this one? Question 28. So correct. This is the basic definition of a normalization, that we try to reduce the redundancy and insertion and update anomaly. So option A is your answer. Just wait everyone, ठीक है? Let me just discuss. क्या इसमें कुछ समझ नहीं आया है? श्रन्या, प्लीज बी क्विक. ओके, जो भी समझ नहीं आया जल्दी जल्दी बताओ. आप अपना क्वेश्चन टाइप कर दिया करो. ओके, जस्ट टाइप योर क्वेश्चन. आई विल मूव बैक टू दैट स्लाइड एंड आई विल अंडरस्टैंड इट कि व्हाट यू आर सीइंग, because otherwise it will take a lot of time. Here, how come PQSTX? PQSTX. इससे पहले वाले में पूछो अब ये. See, we have tried to find the common attribute between the two. PT was the common attribute, and when I took the closure of PT, I got PTX. If you see this, if you see this thing, you are having P determining YX. So I told you that you can break this as P determining Y and P determining X. So now since T is not on the right hand side, so I can include T, because अगर आपकी ये attributes हैं, P is determining X and P is determining Y, so you can take, since they are not having T in them, if I talk about PTX has table, so T अगर नहीं है right hand side पे, so while finding the candidate key I can include T in it. So if I try to find the PT closure by the help of this functional dependencies, I'll get P, T, X and Y. So if you see here, so y तो आपकी टेबल में है नहीं, so I can exclude y. So PT is able to determine x. So PT will become the candidate key of this relation, of this table. So that is why I can join P, Q, S, T and X. So that is why I have combined the two tables, that is these and these, and similarly I have combined these two tables, that is these two, and then I tried to find the common attribute, and then I carried on with the original work जिससे चल रहा है आपका. Okay, right. So moving on, next question is, which of the following statements are not correct? Okay, so they have given you 4 statements and they're asking that which of the following is not correct. So what do you think is the answer, everyone? Ma'am, we have a comma between P and Q. क्या दिक्कत हो गई इसमें? हाँ, कॉमा है पी एंड क्यू के बीच में, राइट? कॉमा, या मुझे बता रहे हो वी हैव कॉमा बिटवीन पी एंड क्यू, क्यू एंड एस? सर्च कर लिया आपने दीपक? So if you see this question, which of the following statements are not correct? So if you see here, 3NF is always lossless and dependency correct, always. Okay, then 3NF is always lossless but may or may not be. This is a wrong statement. 3NF is always lossless and dependency preserving. Okay, then we have BCNF is always lossless and dependency preserving. This is also wrong. The correct is BCNF is always lossless but may or may not be dependency preserving. So correct answer is option number D, that is S2 and S3. So okay everyone, so Deepak has checked the question and he is saying that between Q and S, in this question between Q and S we are having a comma between these two. Okay, so if there's a comma between these two, then it is very well understood कि कैसे होगा question आपका, है ना? then तो कोई problem ही नहीं है if you have a comma between these two. So this is the QS. Now you can take Q common and you can perform the following. ठीक है? Okay, so moving on with the next one. Consider the relation schema A, B, C, D with the following functional dependency set. Okay, and you have to identify the highest normal form satisfied by the relation R. कॉमा होना चाहिए था because they will not give a question like this जिसमें आपके पास you have two things like QS and S and QS is combined and Q is a single, so there are very less chances that you will get like this, something like this, because क्योंकि your logic is right कि you can find Q candidate key and then QS will be the super key, but generally ऐसी चीज़ें they will not give because they ये चीज़ें थोड़ी सी आपकी, मुझे लगता है कि it is like कि जब S यहाँ पे नहीं है तो there are two different things, right? If S is not there, then there are two different attributes. QS is a different attribute and Q is a different attribute. So I think that is why तभी I thought that there is a difference in this question, because ऐसी चीज़ें वो will not give you, they'll be direct with the questions because our questions already बहुत घूमे हुए होते हैं. Okay, so what about this one? So they have given you functional dependencies. A is determining CE, B is determining D, and AE is determining D. So what you can see that A is not there, B is not there, C, D is there. So we'll try to find the closure of AB. So closure of AB will be A, B, then A से you will get CE and B से you will get D. So AB is your candidate key. Any else? No. No else will be a candidate key because anything else other than AB will be a super key. Okay. So now let's see. Now check this first functional dependencies. What it is saying that for 1NF तो है, ठीक है, 1NF है because they have not mentioned anything about कि atomic values हैं या what they are multi-valued, so nothing they have mentioned, so by default we will take it as atomic attributes. So 1NF though they are definite. Let's check about 2NF. So 2NF says that there should be no partial dependency, right? Partial dependency should not exist. Now if you see in this one, what does partial dependency says? Partial dependency says that if you have a part of key, right, part of key is determining a non-key attribute. So now if you see that A is a part of candidate key and it is determining non-key attribute, so this one is a partial dependency. This again is a partial dependency. So I have two partial dependencies, so 2NF will not be the case, so answer will be 1NF. Clear? Now this one, consider the relation. So they have given you A determining BC and C determining D. So what do you think? Which relation it is in what normal form? Okay, Sharanya. Okay. So what about this one? So I have A, B, C, D are there. So I'll try to find the closure of A. So what will be the closure of A? Closure of A will be A, B, C and D. Right. So that is why candidate key is A. Correct. Now this for 1NF is confirmed. 1NF is confirmed. Let's check for 2NF. Is it 2NF confirmed or not? So 2NF says that partial dependency should not exist. So if you see here, if you see this one, so this one is not a partial dependency, right? And this one is also not a partial dependency. So no partial dependency is existing. So that is why it is 2NF as well. Let's check for 3NF. What does 3NF says? 3NF says that either if I have this X determines Y, so either X is super key or Y is prime attribute. Either of the case should follow. Yes. So now if you see this one, this case is following this because A is your super key. But if you see here that C is not a super key and D is not a prime attribute. So 3NF is not followed. So in that case, the correct answer is 2NF. Correct? Okay. So this is how you will find. So in 3NF, there is a bit of relaxation that either your X should be a super key or your Y should be a prime attribute. So A is my super key, but in this second functional dependency, C determining D, neither C is a super key nor D is a prime attribute. So 3NF will not exist. Now, moving on to the next question. Which one is correct with respect to RDBMS? Okay, so they have given you three keys: primary, super and candidate, and they're asking you that according to RDBMS, which of the following is the correct explanation or correct relation. So very easy it is. So if you see, the correct answer is option number B. That is, primary key is a subset of candidate key and candidate key is a subset of super key. Okay, so primary key is a subset of candidate key and candidate key is a subset of super key. So you can have it like this. This is your primary. This is subset of candidate key and super key will come above it. Okay. Next, the multi-value dependencies can be eliminated using dash normal form on dash normal forms. So this is also very easy if you know that multi-value dependencies किस में आता है. If you are aware of this, you will be able to do it quickly. So correct answer is option number D, that is fourth and BCNF. So if I have multi-value dependencies, I can eliminate them by using 4NF and on what? On your BCNF. Okay. Next. So let me give you few questions now. Okay. Just let me write it. So you have a relation R and you have A, B, C and D, and the functional dependency is given to you is AB determining C, sorry, AB determining D. Okay, then we have AC determining BD and B determining C. So you have to tell the highest normal form. So this, which is this question? This is 34. Question number 34 it is. Okay, so you have to tell the highest normal form. Yes, quickly. Yes, quickly everyone. What is the answer for 34th? Okay, so let's see what will be the answer for this one. So if you see here, we have D, B, D and C. So we don't have A over here. So we'll try to find the A closure. So it will give you A. Then it won't give you anything else. है ना? A will give you simply A only. So we have to take other attributes as well. So I'll take A, B. So single A will not let me take, will not let me find any other attribute. So A, B say D and B say I'll get C. So this is your one, and then we have AC. So we will have A, C and then B, D. So this will also be there, and let us try to find AD. So if I take closure of AD, I'll get only AD. So what are my candidate keys? My candidate keys are AB, comma, AC. Right. Now nothing is given to me, so this is very clear that it is in 1NF, because 1NF agar matlab they will mention whether you have a multi-value attribute or not. Okay, let's try to find for 2NF. So 2NF says partial dependency should not exist. What is partial dependency? Part of key determining a non-key attribute. Okay, so AB is a key, so no problem in this question, right? In this also there is no problem. Now if you see this one, if you're talking about this one, so what is partial dependency says? Partial dependency says that part of candidate key should derive a non-key attribute. It is non-key attribute, right? If you see here, B is a part of key, correct, but C is a prime attribute. C is not a non-prime attribute. So that is why 2NF is also there. It is in 2NF as well. So all those who are saying 1NF, I hope you got this point, that B is determining C and C is a prime attribute. So that is why it will be in 2NF. Now let's check for 3NF. So what is 3NF? या तो X must be a super key or Y must be a prime attribute. So super key, and this is your prime attribute. So 3NF is also there, right? And let's check for BCNF. So BCNF says that X should be a super key. Super key, but this is not super key. So the correct answer will be 3NF. I hope this is clear to everyone. Any doubt in this question? Yes, everyone, any doubt? Clear है वाला? हाँ, आप कर सकते हो. You can start from BCNF as well. You can start from BCNF as well, but I prefer it like doing this way, so that concepts when you're practicing the questions, okay, so what you should do is कि you have to practice in such a way कि आपके concepts revise होते रहे. Okay, prime attribute are those attributes that are part of your candidate key. So if I talk about this question, what are my prime attributes? My prime attributes are A, B and C. Okay, these are my prime attributes. Okay, and what is BCNF? If you know this, if you have taken my normalization class जो मैंने ली थी, वहाँ पे I have clearly mentioned that what are the conditions of BCNF. Okay, I'll repeat quickly over here again so that you all are aware of it. But if you have not seen, please do visit normalization class. Okay, anybody can send the can please link the class in your Telegram group. Please link कर देना वहाँ पे. So it says that partial dependency should not exist. Okay, so this is the case of 2NF. So what it says is, what is partial dependency? Partial dependency is that key you are having a part of key, that is any candidate key is determining a non key or a non prime attribute आप कह सकते हो. ठीक है. 3NF says that X, if I have X determines Y, so it should be that either your X is a super key or Y is a prime attribute. So this is the case that 3NF follows. अगर इनमें से एक भी इस condition is true for any of the following dependencies, then it is in 3NF. BCNF is a bit stricter than 3NF. BCNF says that if I have X determines Y, then X should be a super key. So these are your conditions that you have to follow for 2NF, 3NF and BCNF. So all those who are not aware of this, मतलब जिनको ये idea नहीं है, please do take a screenshot of this and please take the normalization class as well. ठीक है? Okay, so I hope you have taken the screenshot for this now. So if you move back to this question, BCNF की condition क्या थी? BCNF says that it should be a super key. So if you take AB, so AB is a candidate key. Since it is a candidate key, it will definitely be super key. AC is a candidate key, it will definitely be a super key. But only B is not a super key. Why? Because B is a prime attribute but not a super key. So that is why this one is not a super key. So this is not in BCNF. So this was in BCNF. ये आपकी BCNF में थी, ये आपकी BCNF में थी, but this was not in BCNF. ठीक है. 3NF says that either X should be a super key or Y must be a prime attribute. So ये आपकी super key है, ये super key है, इस वाले में ये आपका prime attribute आ गया. C is a prime attribute because B is not a super key, but Y is a prime, C is a prime attribute. So that is why it is in 3NF. Okay. Now, moving on to the next question. This is question number 35. So it says that suppose you have a relation R, A, B, C, D, E, F and G, H. A, B, C, D, E, F and G, H. And functional dependencies are A determining B, C determining D, E determining A and F determining GH. Yes, yes, Kusum. So you have decomposed it into जहाँ पर decomposition हुआ, it is into E A B C D F G H. There, these all are different attributes. ठीक है, common लगा हुआ इन सब में E and F. So you have to tell whether it is lossless, lossy, dependency preserving or not. So do it. So now after this, this will be an over for your normal forms, because इससे ज़्यादा normal forms आपके अगर मतलब if you are able to do all these questions, you will be able to do it clearly, correctly. ठीक है. So tomorrow we will be starting with your SQL, relational algebra and your tuple relation का जो भी आपके questions मुझे मिलेंगे, tomorrow we will do those questions. ठीक है. So tomorrow we will discuss. Tomorrow तो class है नहीं होगी, कल sorry class नहीं होगी. Okay. Tomorrow there will be no morning class. Okay. I have to go somewhere. So tomorrow there will be no morning class. The morning class will be now on Wednesday. So we will include all the three that we have. ठीक है. And plus let me check if I can add. वही तीन काफी रहेंगे. आप just revise those three concepts only. ठीक है. SQL, relational one and your tuple relational one, TRC. So complete this quickly. How C is prime attribute? Shuranya, C यहाँ पे C इसलिए prime attribute है because C is a part of candidate key. All those attributes that are part of candidate key are your prime attributes. प्लीज मेरी वो नॉर्मलाइजेशन वाली वीडियो देख लेना. Please everyone, I'm repeating again and again, there is no use of doing these questions if you're not clear with your concepts. Okay, concepts clear नहीं है तो आप नहीं कर पाओगे क्वेश्चन, चाहे आप कितने भी क्वेश्चंस प्रैक्टिस कर लो. No matter how much questions you practice, if you are not clear with the concepts, you won't be able to do them. Yes, what about this one? मिनिमल कवर का क्वेश्चन एम्बली आई हैव टू ऐड, बट मुझे मिला नहीं है वो क्वेश्चन. सो आई ऐड दैट पर्टिकुलर क्वेश्चन इन द नेक्स्ट सेशन. ठीक है, एक क्वेश्चन है आपका यूजीसी का ही क्वेश्चन है वो. सो आई ऐड इट. ओके, शरण्या प्लीज आप वो देखो. ठीक है, वीडियो नॉर्मलाइजेशन की वहां पे अगर आपको नहीं समझ में आए तो आप मुझे तब बताना. ठीक है, प्लीज एक बार जस्ट डू विजिट दैट वीडियो. नहीं तो व्हाट यू कैन डू इज कि आप इसी वीडियो को दोबारा देख लेना, आपको और समझ में आ जाएगा. ठीक है, yes B2, this is a very important topic. Normalization DBMS का one of the most important topics है if you talk about computer science. ठीक है, so if you are willing to become a computer teacher, you should know this topic. So you are saying lossless and dependency, everyone. Lossless and dependency only. Achha, some people are saying lossy also. Chalo, let us see. So first what we will do, we will combine the two. What we will combine, if we have anything in common from this, so we can combine these two first, right? So if I combine it, what will be the common attribute? F is the common attribute. Okay, and if I try to find the closure of F, what I can get from closure of F? I can get F G H, right? And this is basically this one. So F is the candidate key for this one, right? So what I'll get now? So it will be E A B C D, and I can combine these two because I have found a candidate key for one of them. So it will be F G H E, right? Now I have to find common between these two. So the common element between these two is E. Let's try to find the closure of E. So E से I can have E A से I can have B and C से I can have D. So E will be a candidate key for this particular relation, right? So that is how this is your lossless. Okay, then let's check for dependency preserving. So A gives BC will be done if I name it as relation 1, relation 2 and relation 3. So relation 1 will take care of this one, C to D also relation 1, E to A also relation 1, and F to GH will be taken care by relation 2. So all the dependencies are taken care of. So it is lossless and dependency preserving. Okay. Yes, वन नॉर्मल फॉर्म में एटॉमिक वैल्यूज होती हैं, सिर्फ मल्टी वैल्यू एट्रीब्यूट्स आर नॉट देयर, ठीक है. सो एवरी वन who is not aware of this normalization topic, because I can see that many people are there who are having doubt with the normal forms, please, it's my humble request, do visit the normalization topic that I have covered in one day one topic series. Anyone who is able to share the link on the Telegram group, please do share the link, ठीक है, so that they can go and visit that class. It is very important topic, it is a very important topic, ठीक है. So this is the Telegram group. If you haven't joined yet, please join it so that you are aware of the topics that we have covered, you are aware of the classes that are going on, ठीक है. So that's it for today. I'll keep it till here only for today. Minimal cover का एक आध question we'll do, क्योंकि minimal cover का एक question आया था I think in 2019 or so, 18 or so, I'm not sure of, ठीक है. So we will do that question, and in the evening class, that is at 6 p.m, we will be having the previous year question, that is paper 1 we will be doing, right? And paper 1 will be of your I think 2018 ka we will be discussing, right? So I'll search for it and then we will discuss those questions, and I think 2 days it will be it will take for discussing the entire paper, okay. So do revise the concepts of paper 1, and tomorrow there will be no morning class, sorry, okay. Tomorrow we will not have any morning class, okay. The morning I have already shared the schedule with you, you can please check that schedule, and accordingly we'll have the classes, okay. So that's it for today, see you all in the evening, okay. Bye bye everyone.